I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. On this channel, I present tutorials on using TikZ and PGF plots. The videos on this channel are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials. Today, I'll show how to draw an artificial neural network diagram in TikZ. This was a request from watcher @MattJunty on episode 65, so thank you for the great suggestion. There are a number of special purpose packages for drawing neural networks, and if you need something more complex than what I'll show today, those may be worth checking out. We're going to create our neural network diagram using pure TikZ. We'll draw a fully connected feed-forward network with 5 layers. We'll add labels to the nodes, and we'll put colored backgrounds behind each group of nodes to visually separate the input, hidden, and output layers. We will use tools that we've already seen in previous episodes, and we're going to put them all together here. So this is nodes and edges, loops, a bit of PGF math, fitted nodes, styles, including a style with an argument, and drawing in the background. So let's get started. In the preamble, I'm using a geometry package with a margin of 1 inch, so I have enough room to draw my figure. I'm loading parskip to avoid paragraph indentation, and hyperref to link the author name to this YouTube channel. The key package is TikZ. I'm also loading 3 TikZ libraries. The positioning library lets me place nodes relative to one another. The fit library lets me create a node that wraps around a group of existing nodes. And the backgrounds library lets me draw underneath everything else. Before I draw anything, I'll do some setup. I'll define 3 colors using HTML hex codes, 1 for each kind of layer, a blue for the input layer, an orange for hidden layers, and a green for the output layer. Now I'll set up some styles for the neurons themselves using the TikZ set command. The neuron style is the base. It's a circle node. We draw the outside of it. The minimum size is 10 millimeters and the intercept is 0. I want to make it 0 so that I can see if the text is forcing the node to get bigger than my specified minimum size. And I should notice that because the letters will be right up against the edge of the node. Then I define 3 styles that inherit from neuron, input, hidden, and output, and each of them just sets a different fill color at 20%. The last prep that we're going to do is we're going to define some macros that we can use in placing our nodes. This isn't strictly necessary, but this will give us flexibility later if we want to change the spacing. So I'm defining a macro xstep, and I'm going to use that to control the horizontal spacing. And then I'm defining the command xpausecalc, which uses xstep to determine the x position for my layer. So the layers will be up and down, and then I'm going to figure out the x position of my next layer. So I just put in the layer number and it'll determine it. So the first layer would start at 0. The second will be at 1 times the x step, which will be 3, and so on. And then for the second part, I want to look at the vertical spacing between nodes in the same layer. So I want each layer to be centered vertically around the horizontal axis. So that means I have to adjust where I am depending on how many nodes are going to be in that layer. So I'm actually going to give 2 arguments to ypausecalc. That is going to be the number of nodes in the layer and then this node's number, and then it will calculate where I should be so that the nodes are centered with respect to the horizontal y equals 0 line. I will use y step of 1.5 since each node is 10 millimeters in diameter, and I'm going to be placing the centers of the nodes. That means there'll be a 5 millimeter gap between the nodes, and then I can adjust that if I want to adjust my node size or I just want things to be closer together. One quick warning is we're going to be calling these macros inside of TikZ and PGF math operations. And I found that if I tried to make that x step and y step into an optional argument, then it didn't work. And that's because things are a bit fragile when you're doing these inside of more complex TikZ expressions or PGF math expressions. We could probably figure out a way to make it work, but I wanted to give you that warning so that maybe you can just avoid that problem altogether by not trying to use optional arguments. So now we're finally ready to draw something. I'll paste a TikZ picture environment with just the first layer of nodes. I'm using a loop here, and so let me kind of walk you through that loop. So I'm defining NNIN for the number of nodes in the input layer, and I'm going to set that to be 4. Then I'm determining the X position for this first layer. So I put 1 into there because it's the first layer, and that'll calculate X pos, and that'll be used for my X coordinate in all my nodes. Then I'm going to loop through my nodes from 1 to nn in, and so that will make a node for each node in this first layer. And then I am using the evaluate option to for each to calculate the Y position based on the node number. And I'm going to use that function we defined above, yPosCalc, and as input, I'm giving it the number of nodes in this layer and the I, which is the position of this node. And so it's going to make them go from top to bottom. So if I compile that, what do we get? So I should note that I'm using node with the input type that we defined above. I'm naming the node in dash the number of the node. So this would be in dash 1, in dash 2, all the way to in dash 4. And then putting text into each node in math, which is x sub I. I covered for each loops with the evaluate option in an earlier episode, and I'll link that in the show notes. Now let's add the first hidden layer, and this time I'm going to use 5 neurons for that layer. And I'm going to use basically the same pattern. I've just defined a different thing, NNHA, for the number of nodes in that layer. I couldn't use NNH1 because you can't have macro names with numbers in them. So I'm going to make the first one A, the second one B, and so on. I'm doing everything else the same as before, except for that I'm giving these nodes a different name and a different bit of text inside of them. When I compile that, then we get our hidden nodes in the first layer. So the layer is the superscript on the H. Now I'll go ahead and add 2 more layers to our picture. So we'll add the second and third hidden layer. When I compile that, this looks identical to before, but now we've got all those nodes in there. Finally, let's add the output layer with 3 neurons. Same pattern as before, but I'm using the output style and I'm giving different naming convention to the nodes. After compiling, we have all 5 layers of our network. Now all the neurons are placed, we need to connect them. This is where edges come in. So before drawing the edges, I'll set up their style. So I'll go back up here to my TikZ set, and I'll put every edge append style, and then I'm going to do dash LaTeX, that specifies the arrow type, and then I'm going to shorten the beginning and end of the arrow by 1 pt, just so that we don't have the arrows touching the nodes. They'll come right up to it, but not quite touch it. Now I'll connect the layers using a bunch of for each loops. So let's go down after we've drawn our layers, and then we'll add our connections. So I'm going to show you a bunch of loops, and I'm going to talk through what they're doing. So let's look at this first loop. I'm connecting the input layer, which has names like IN-1, 2, 3, and 4, to the first hidden layer, which has names H1, 1, H1-2, so on down to 5. So this loop goes from 1 to NN in, which is 4. And then I have a path command starting at my input node, and then I have a for each inline inside the path statement that is going to create an edge from in-I to each of the hidden layer nodes. I'll note that the braces are required around this edge statement so that the for each loop knows what's inside of its loop. And I repeat this pattern for the other 3 layers. When I compile that, we then get all of our arrows for our fully connected neural network. I covered nodes and edges in more detail in an earlier episode, and I'll link that in the show notes. Now I'd like to put a colored rectangle behind each group of layers to visually separate the input, hidden, and output layers. To do this, I'm going to set up some more styles. I'm going to go back up here into the TikZ set zone, and I'm going to put fitted.style and args equals 2, and then my arguments. So the first argument is to a list of nodes that we're going to fit. And the second argument is just a color. So argument number 1 is passed to the fit option. So that comes from the fit TikZ library, and it will contain all the nodes that you give it as a list. Argument number 2 is the color, which I'm going to use at 5% to fill the fitted node. And then I go on to specify the inner separation in the X and Y directions, and then I round the corners. I covered styles with arguments in more detail in an earlier episode, and I'll link that as well in the show notes. Now I'll go down to the bottom of my picture And I'll add a scope with the option on background layer from the TikZ backgrounds library. So I'm doing that because I want to draw behind the nodes rather than on top of them. And then inside this scope, I'm creating 3 fitted nodes. So the first one is going to fit in-1 and in-NNN, which is just 4. And I only really need to specify the 2 outside nodes, and then everything in between will automatically be included. For the second layer, I'm going to put a box around all the hidden nodes. So I'm going to give the top and bottom of every single set of nodes. That way, even if I change the number of nodes in one of the layers, this fitted node is still going to work. For the output layer, it's the same idea, but I only need the top and bottom node. So when I compile that, then we see our fitted boxes around those nodes as a light background color. I covered background library in another episode, and I'll link that also in the show notes. Next, I'm going to add labels to these 3 colored regions. I'll define one more style up above called title that will take one input argument, which is the thing it's going to be the title of, a pointer to that node. And then I'm setting the node font to be large and the alignment to be centered. And I need that alignment to be centered because I'm going to have some line breaks inside my nodes. And if you remember, line breaks do not work unless you specify the alignment or text width. So now I'm going to go back down and I'm going to add 3 nodes. It could be inside or outside of the scope. It doesn't really matter because it's actually not on top of anything. And then I get my titles, input layer, hidden layers, and output layer. Now we have our complete network diagram. So let's see how easy it is to change the number of nodes in each layer and the spacing between layers and between nodes. So to change the number of nodes in a layer, I could just change that macro I defined. So suppose I want to change the number of nodes in the 3rd hidden layer from 4 to 7. I just change that to 7, recompile, and I magically now have those 7 hidden nodes. Everything is adjusted automatically, all the edges in between the nodes, the size of that box around it. So I can make that change very easily. I can also go up here and I can change the spacing. I could make this be a little bit tighter with 1.2 and 2.5. And now my neural network gets a little bit smaller on the page, which maybe is useful if you don't have as much space. Let me undo those changes and we'll just go back to what we had before. For the finishing touch, I want to highlight one path through the network and label the weights along it. So I'm going to go down here. I'm going to start a new scope at the very end. And inside that scope, I'm going to change the node and edge options to my preference. And because I'm doing it inside a scope, I can just do it for every node and every edge. I don't have to define a new style again. And so what I've done is I'm drawing a path from in-4, that's this node here, to h1-1, that's this node here. And then I'm drawing it extra thick. And then I'm adding a node on top of that that gives that this is the 4-1 entry of the first weight matrix. That's what that math says there. This node automatically went midway because I didn't specify it and it was between edge and the closing node. And then I had set all the every node properties. So it's sloped, which means it gets on the angle of the line it's on. It's above it. And I filled it with white, and then I set the fill opacity to be almost 1, but just a little bit of hint that you can see through it. And then I added 4 of those just tracing through our network. I hope you enjoyed today's episode on drawing a neural network diagram in TikZ. We used a bunch of TikZ skills such as nodes and edges, loops with a bit of PGF math, fitted nodes, styles, including a style with a named argument, and layering with the background layer library. This drawing was motivated by a comment from Maddie Junti, so thanks for that excellent suggestion. I include a link to the overleaf document I created today in the show notes. If you found this helpful or interesting, please click like or subscribe. If you have TikZ or PGF plot questions, please post them in the comments. I love to answer watcher questions. If you want to learn more, please check out the other videos. I also have a book, Unlocking LaTeX Graphics, available for purchase at major book retailers. Thanks for watching.